I would be happy to do. Number 4. 9m cubed plus 54m squared. So remember, my first step is always looking for that GCF. So does this have a GCF? Yes, what is it? 9m squared. And if I take that out, what's left? You can't do anything else with it, so you stop right there. No, it doesn't matter. It's not pretty, but it doesn't matter. What else? What? Like y'all are factoring pros now? Yeah? Nice. Probably have a quiz soon, but not today. We just took one yesterday. But it was a little late, so, but it's going to be soon. Oh, they usually take 15, 20 minutes, and then we'll move on. They don't take the whole class series. All right, let's talk about, I got 2 things to talk to you about today. First thing is, I say it's optional. It's optional until we get to a certain point, and then it's not optional anymore. But we're going to talk about factoring special patterns first. And there's only 2 I'm going to talk to you about. And they're just little tricks that are going to help you right now factor a little faster if you recognize that the pattern's there. So I'll start with the easy one, and then we'll move into the one that's a little bit harder. You may have already figured out a couple of these, depending on how, I guess, how attentive you were to some of the things. But if you didn't pick up on it, it's okay. All right, so here's what I want you to do. I want you to think about this. And I want you to look at it, and I want you just to factor that like normal really quick. That's your factoring pros. Easy, right? There's no B, but there is a B. It's just 0, right? So factor it like normal, see what happens, see what you get. Marset, go. Try it. This is what you did yesterday and the day before. Anybody stumped at this step? No. What factors did you get that multiply to -9 but add to 0? 3 and -3, right? And we're just going to fill in. I always put the negative first if they're mixed signs. It helps me so I don't have to change that last sign. GCF, here's x, leaves me with x minus 3. GCF is 3, leaves me with x minus 3. Did everybody get x minus 3 times x plus 3? Yeah? What relationship do you see between what I started with and what I ended with? They are multiplying, but what's special about what's being multiplied, about those values? What's that thing? Square root, right? They're squared. The relationship here is each of these values are the square roots of each n value. And I've got one with the plus and one with the minus. That is what we call a difference. Difference means what? Subtracting, and that's really important because this only works when that middle sign is a minus. But this is called the difference of 2 squares. Now, if you don't remember what a square means, remember that's something multiplied by itself. Give me some examples of perfect squares. 1, 4, 9, 16, 25, 36. I was waiting on y'all to start picking. Y'all see what we're doing? Okay. Times itself to give you that value. Those are perfect squares. Okay. So if I have two perfect squares separated by a subtraction sign, just like I had here, and I'll do another one. Let's say x squared minus, we'll do 25. Then I can factor that by doing the square root of each of them, or what times itself 2 times gives you x squared? What times itself twice gives you 25? 5. You do 1 minus and 1 plus, and it is factored. Okay. In general, this looks this way. A squared minus b squared will always factor as a minus b, a plus b. That is the difference of two squares. Now, as you can see, you don't have to know that special formula. You don't have to know that special pattern. You can go through and do it on your own. It's just going to take a lot longer. When you can recognize it, it makes it quick, and it's a lot less room for mistake because you know it's easier to take the square root than it is to find the two factors, slash it, GCF, and go on from there. You actually could do it if it's a GCF still, as long as they're both perfect squares. So, like if I had 16x squared minus 4, I could still do it. When I factored this, I'd get 4x minus 2, 4x plus 2. And what I'd have to do is I'd have to take a GCF out of both of those in the end if I didn't in the beginning. But it'll still work. Factor that one. Can you use the pattern? Yeah, they're both perfect squares, minus in the middle. What's it look like when it's factored? 7x minus 3, 7x plus 3. Y'all okay on difference of two squares? It's a pretty easy pattern, right? Just be careful. You can't factor that one. You can't do it. Why can't you do this one? And if you put this together, if you think about this the way we've been doing it, right? 25x squared plus 0x plus 4. If I multiply the ends together, I get 100x squared. What multiplies to 100 but adds to 0? That multiplies to negative 100. That adds to 20. See why it doesn't work if it's plus? There's nothing it doesn't, the factors don't work. This is a cannot be factored problem. It's already, you can't do anything else with it. Yes or no on, okay? All right. The other pattern is a little bit harder to recognize. This is one that you will probably look at it and you'll go, oh my gosh, I'm just going to do that one like I normally do, and that's fine. But when we get to the end of this unit, you will have to be able to recognize this pattern, okay? So I suggest going ahead and learning it now, but that's definitely up to you. But it's what we call a perfect square trinomial. Now, trinomial means it has 3 terms. Most of our quadratics do have 3 terms, but they don't have to. This one has to have 3 terms. All right, so I've got 3 things. 1, 2, 3. And let me run through the stipulations, because the hardest part about factoring a perfect square trinomial is recognizing that it's a perfect square trinomial. First thing that has to happen is this second sign has to be plus. The second thing that has to happen, the first term and the last term have to be perfect squares. First and third. And now the last step is the hardest. The middle term. I like to call this square dancing, but however you remember it. If you take the square root of both ends, okay, so we're going to say this is step 3. We take square root and we take square root. And we multiply them together and then double them. That has to be what sits in the middle. So I always say it has to be square, square, multiply, and double. Y'all ever heard about square dancing? Your grandparents might square dance. Did you really? Oh, well then you know. So whenever I'm saying square, square, you understand why I'm saying square anyway. Do y'all remember how to do it? I can't believe y'all learned that. That's pretty cool. You do-si-doed? Yeah. We should do a project where we make up a square dance for the perfect square. Really? So it's the square root of the first times the square root of the last, and then you double them after you multiply them together. And I'm going to show you an example of what this looks like. But those are the requirements. So in a more general form, it looks like this. You have something squared, you have a plus sign, and you have something squared. And in the middle, well, what times itself twice gives you a squared? A. What times itself twice gives you b squared? B, and you have to double it. If this happens, and notice I did not specify the first sign because it could be a plus or a minus, it doesn't matter. If this situation unfolds and you have this, then to factor it, you just do the square root of the first one. This is whatever sign comes first. Whatever's here goes in the middle. And then the square root of the last, and you throw a squared on the end of it, and you're done. So I'm going to show you an example, and then we're going to practice recognizing when it's a perfect square trinomial. So good? Is that a perfect square trinomial? And look carefully and go through all your steps. I heard yes. Is the second sign a plus? I do not know who did that stupidity. They taped up the whole stinking calculator. Are the ends perfect squares? Yep. Got one here. Does the middle term, does the whole thing square dance? In other words, if you do the square root times the square root doubled, do you get what's in the middle? Yeah, well, because what times itself twice gives you 49x squared? 7x. What times itself gives you 25. 5. 7 times 5 is 35, and 35 doubled is 70. So all I have to do is throw this middle sign here and put a square. Now I show you this one because what if you didn't know that pattern and you had to factor this by hand? That yep. That first sign, just ignore it. It doesn't matter. It just goes in the middle there. What if you had to do that by hand? What if you had to say 49 times 25? Somebody tell me what 49 times 25 is. Because I don't know. That's a lot. What if you had to find two factors that multiplied to that but added to negative 70? Holy crap. You'd be here all day, right? No, you get it? You'd rather do it the long way? No, but you're just good like that. You could find those two factors. So yes, you could do it that way, but you see how easy it is to use the pattern. You see what I'm saying? Okay. Let me give you a couple examples. You tell me yes or no. Okay. Sorry, I have to try to get through it in my brain. Tell me yes or no, is it a perfect square trinomial or not? If no, what can we do to make it a perfect square trinomial? And then we're going to factor it. So look at the first one. Yay or nay? I heard no and I heard yes. I heard it is. If you say no, why do you say no? The middle's not doubled. So 2x and 3, and I intentionally put this because it's so hard to remember to double, because you look at it and you go, oh yeah, because they're together, but you got to double it, right? So to make this a perfect square trinomial, this middle would need to be 12x. Now it is a perfect square trinomial. So now if I factored it, what would it look like? Y'all can do it. 2x plus 3 squared. Y'all okay? Look at the middle one. Yay or nay? No again. What's keeping it from being a perfect square trinomial? That second minus sign. All I got to do is change that. Is it now? Yep. How would it factor? Yes or no? What about the last one? I heard no. What's keeping it from being a perfect square trinomial? The middle number. What's it need to be? All right, so 12x and 4. So it is, right? The way it sits, it is. So how does it factor? That one technically had a GCF I could take out of it, but I wanted to put some big numbers in there to show you it still works. Tell me what you think about the two patterns. Yes, but if you did, I would advise you to do it in the beginning, because if you take it out here, really squared means this. So if you took the GCF out, you'd have to take the GCF out of this one. That would be a 4. And then you'd also have to take the GCF out of this one, which is another 4. So I'd have to do 4 times 4, and then each one of these. So it would actually be 16 times 3x minus 1 squared. So if you took the 16 out here, it sets you up. I would rather you take, this is the one that I would want. I would want you to take the 16 out first, so that then you would get, should be 9x squared. What do you get? Minus 6. And then this is the perfect square trinomial. All right, I got one more thing to show you. Are y'all ready? You need a break in between, or are you okay? Yeah? All right, here we go. The reason we factor and the reason that we do everything in the rest of this unit, the whole rest of this unit revolves around the exact same concept. Every new thing we learn, we will be learning so that we can do this, and that is to solve a quadratic, okay? If you have a quadratic, that looks like this, and I said, solve that for x, what would you do? That's what everybody wants to do, right? Subtract 2. Okay. If I move the 2, now what happens? Remember, I'm trying to get x by itself. I hope you're stumped because you can't do anything there, right? There's no way I can get x by itself with the methods that I'm using, so I have to adopt a new method I have to figure out. So this is not going to work. But I want you to think about something for just a minute. What happens? So I've got this equation that equals 0, x squared plus 3x plus 2. What happens if I factor this? So just factor that real quick. Tell me what you get. So what y'all got? And you're probably looking at it going, yeah, but how does that help me solve, right? Do you agree that when you factor, what you've come up with is a multiplication problem? You've got something times something else. Well, notice what these two things equal. What do I have them equaling? 0. What is the only way to get 0 when you multiply two things together? One of them has to be 0, right? One or both of them has to be 0. There is no other way to get 0. You can think of anything you want in your head. There's no other way to get 0. That is what we call the zero product property. It says if two things multiply together to give me 0, then either one or both of them is 0. There's no other way. So what we do is we say, okay, well then this piece must equal 0, and or this piece must equal 0. So I've got two possible solutions here. And these are easy one-step linear equations here, maybe two-step at the most. But I could subtract 2 and get x equals negative 2. And I could subtract 1 and get x equals negative 1. And I would have two solutions. Now I've solved my equation for x. So that's why factoring is so handy for us, is it allows us to solve a quadratic equation. Okay? So the only new thing with factoring here, so to solve quadratics by factoring. In order to use factoring, lets us use that zero product property, right? But in order to use it, it has to equal 0 first. So first thing is make sure your equation equals 0. Most of the time it's going to equal 0 for you before you even start. But make sure you go back and make it equal 0 if it doesn't. Then we're going to factor as much as we can. That's going through. We'll look for a GCF. That's always the first step. Then we're going to add in there now, instead of just looking for a GCF and jumping into factor, we're going to look for a GCF. Then we're going to look for a special pattern. In other words, is it a difference of two squares? Is it a perfect square trinomial? And then if not, we're going to go ahead and use our slash method and factor it that way. But either way, we got to get it factored down. And then the last step, we're going to set each, and I'm going to say each piece here, equal to 0 and solve. Put in parentheses, possible 2 answers. And we'll start talking about what that means and why we get 2 answers and what happens. Right now, we just practice with the algebra of it. What do you think? All right, let's do a couple examples and then I'll set you loose. If you got it and you don't need any more help with it, I don't want to bore you. I am going to pass around your homework and you are more than welcome to start on it. Remember, if you're an early finisher, don't forget that Khan Academy. We've moved into the factoring part now, so there's a lot on factoring and solving and special patterns in there. So you can get to work on that also. I'm going to do a couple more examples with you, things that come up frequently that students struggle with, to make sure that you understand. In fact, I might even do 1 or 2 that are on your homework. I think I will. I think I'll start with number 9. Number 9 is 2x. No, let me not start with number 9. Let me start with an easy one. I don't want to do all of them for you, though. Let me start with one off the top of my head, then I'll come back and do number 9. Let's do 2x squared No, this one's not, but then I'm going to do the next one I do will be off the homework. How many more you need? How did I not run any extras? Okay, sorry. All right, first step, does it equal 0? Yes, if it doesn't make it, but it does, so I'm good there, right? All right, look for GCF. Nope. Special pattern? Nope. Okay, well then I just have to go into factoring old school, right? What multiplies to negative 14x squared but adds to 5x? Seven and negative 2. I'm going to put my negative factor first. You don't have to do that. I find it makes it easier for me. And I'm going to slash. What can I take out of the first 2? 2x. What's left? X minus 1. Middle sign stays. What can I take out of the last 2? Yep. What's left? There you go. So fully factored, this quadratic looks like x minus 1, 2x plus 7 equals 0. Nothing new here, right? That's what y'all are the best at, just factoring that quadratic through. Now what? Set each piece to 0. I'm going to do x minus 1 equals 0. That's exactly right. And I'm going to solve each one. So for this one, I'm going to add 1 to both sides. There's one solution. This is a little two-stepper. Or negative 7 over 2. Or negative 3.5 if you like decimals, it doesn't matter. How could I check to make sure that the answers that I got are the right answers? Plug them back in. If you want to check, plug them back in and they'll work, right? If I plug these in for x at this point, back up in this equation, I'll get 0. It'll equal 0 when I'm done. Let's do one more. Let's do number 9. Somebody tell me what number 9 said on there. I just remember I wanted to do it. Thank you. It's very close by. Thank you. All right. Step 1. Make it equal 0. It doesn't equal 0 right now. So now my question is, what should I move where? Because I got one thing on both sides. And you might not know this yet because I haven't mentioned it. But always try to keep whatever the squared term is, try to keep that positive. It'll make it easier for you in factoring. It won't be wrong the other way, but I always try to keep it positive. So if I keep that 2x squared positive, what needs to move? The 5x. So I'm just going to bump that to this side. To do that, I'm going to subtract. This is one of the easier problems because students always struggle with this for some reason. All right, I've made it equal 0. Step 2, factor. In order to factor, I first look for a GCF. Does it have a GCF? Yes, it has a GCF of x. If you take out x, what's left? Okay. Can I factor anything else? No, nothing else factors, right? I'm done with that step. What's your next step say? Set each piece or term to 0, right? So what do I do? You see 1. Say that one more time, Chase. X equals 0. That's the one everybody always misses. I'm impressed. This is really x times this, right? So that's one of your multiplied pieces. So this can be 0, or this can be 0. Well, this one happens to just already be solved the way it sits. Easy peasy. This one I have to do a little more. I need to add 5 and divide by 2. But there are my two solutions. X equals 0 and x equals 5. No, not for this one. Does that make sense? Tell me what you think. Ready to go? The only other little tidbit, and then I promise I keep saying I'm going to be quiet, and then I keep talking. If you end up with something that looks like this, right? And so I've got this GCF on the outside. This one I set equal to 0 because it was an actual variable. This one, if I set that to 0, that makes absolutely no sense, right? There's nothing. Remember, you're solving an equation trying to find a value for a variable that you can plug in and make it true. I could never plug something in to make 2 0. That's never going to happen. So this does not impact your solution, and you move on to B. Okay, so if you've got a GCF outside without a variable, it does not impact your answer. Just look at the factor key. All right,